All right, problem of the day, number 1, Unit 3. An E1 reaction, very similar to something from our test in Unit 2. What's the first step in an E1 reaction? The first step is a leaving group leaves. So that's what happens. Leaving group leaves. And at this point, we actually don't need to even worry about drawing it as a chair anymore, because we don't need to worry about things being anti-periplanar. We don't need to worry about things being anti-periplanar. So we're thinking about Zaitsev. We don't need to worry about things being anti-periplanar. When we do eliminations, we want to find those beta hydrogens. So how many beta hydrogens are there? I see 3 in 2 types, but only 1 leads to the more substituted alkene. So I take my bulky base that's unreactive, and I do this elimination. Elim, and that gets me to actually the final product. Key points: leaving group leaves, that's the first step. It's more than one step. It's an elimination reaction. You got to find the beta hydrogens. If you can, with an E1, you don't need to worry about things being anti-periplanar, right? You don't need to worry about things being anti-periplanar. So then you're going to do Zaitsev's rule to make the more substituted product. All right, this problem. The second problem from that problem of the day, problems of the day. So what kind of reaction is this? It's not a halogenation. How do I know it's not a halogenation? In a halogenation, you add 2 halogens, right? And here, I'm adding 1 halogen and then something else. So it's a halohydrin reaction, where we add a halogen but then some sort of polar protic species. So the first step has how many arrows? How many arrows in the first step? 3. Pi bond reacts, breaks the bromine-bromine bond, and then the bromine lone pair comes back towards the pi bond. Make sure this arrow, right, 1 goes to the bromine and 1 comes away from it. Make sure the direction of these arrows are done correctly. So you make that bromonium ion. Make sure we have a plus charge on our bromine. You also made Br minus. Now in this case, if we numbered our alkene 1 and 2, carbon number 2 is more substituted. That's where our nucleophile or solvent, the polar protic species, is going to react. So that's where it does. This is that SN2 like. You need to make sure you break the carbon-bromine bond as well. So SN2 like. So we got our 5-membered ring now. So this was carbon 1, this is carbon 2. Common things people will forget. They will forget this plus charge. There's a last step for these halohydrin reactions. Same with oxymercuration, demercuration. The last step is a deprotonation. So the last step is the bromine here is going to take one of these hydrogens. You need to show these 2 electrons going to that hydrogen as well. So there you got your deprot to get to your final product. This halohydrin reaction.